year, through even my contact, about 5 to 6 women researchers have got this leadership program. All of them are from Tier 2 and Tier 3 institutions. None of them are from Tier 1 or IIT and IIT. In fact, IIT and IIT faculties are not allowed to participate in this leadership program. So it's a very easy scheme for the women researcher to secure if you are from the Tier 2 or Tier 3 institutions. Some faculties may ask whenever I go to colleges, like, do we have internship like a faculty students? Yes. Karyashala, Ritika, INSA visiting scientist program, and IIT Delhi summer faculty intern. These 3 programs allow faculty to have an internship at either IIT or NIT. And like female, for both the genders, IIT Jammu has launched the leadership program sponsored by Ministry of Education for a week. This is a very good program for all the faculties to learn the leadership skills. And like women startups, both genders, to support the startup, DST has Nidhi, Prism. These 2 programs support funding for the startup. Okay. And if you are interested in postdoc, Inspire or Negru Science is the best postdoc available in the country. In fact, Negru Science postdoc will allow you to work under at CFCR labs. Similarly, for the PhD, Prime Minister Fellowship, US India Entrepreneurship Fund. These 2 fellowships give you the good grants. The Prime Minister Fellowship is that one of the IITs, they pay you about 1 lakh per month. US India Entrepreneurship Fund allows you to do the PhD abroad, which are very good grants. And Inspire postdoc will give you about 1.2 lakhs per month as a stipend. And recently, AICT has launched AICT PG certificate program to support, in fact, to help all these faculties who are suffering from recession in the academic sector, like mechanical, EEE, or civil engineers faculties. Though they have put decades of experience, because of the lack of admissions, they are mercilessly fired by the institutions, because now academic institution also is a profit driven and market driven. So like in software industries, the academic industries also, you see the academic, I don't call you industry, but that is the way it's currently running. Academic sector also is prone to recession based on the market, the students' interest. So only the now computer science allied branches are having a higher admissions, whereas some of the core branches don't have the admissions presently. So in order to save these faculties, IICT has launched a PhD certificate program in the emerging technology. Suppose you are a mechanical faculty, you are allowed to do the PG certificate in cross-disciplinary, that is circuit branches one, like machine learning or cyber security kind of things, and vice versa. So this will help you to teach in the department in the event of in the situation where you don't have admission in your department and you want to continue in the academic career. This certificate will help you. So I urge all the faculties to apply for this PG certificate and obtain, so that you can make your career more immune to this kind of a recession. Okay, and this is not only for the suffering branches, also for the prosperous branches, because academic sector is highly cyclic in nature. Branches which were flourishing in 2015-16 are now doing very poor, and same goes after 3 or 4 years down the line. All these prosperous computer science allied branches, due to oversupply of graduates, suffer the same problem. So it is prudent to study or obtain the PG certificate and upgrade your skills. So in industry, we call it upskilling. So upskilling is a necessity these days for all the faculties. So you cannot be just a teacher and age-old, traditional curriculums we keep teaching. You have to upgrade. Your curriculum has to get upgraded. Everyone has to embrace AI in their artificial intelligence related stuff in your curriculum to stay updated and stay advanced in the present education sector. And some faculties may ask, I'm not interested in research grant. Do I have any other mode wherein I can, get a grant to travel abroad to present my paper or organize some events in my college through government funding? So all these funding agencies, whoever I told, they have a schemes to fund academic institutions, either to have some conference, seminars, or workshops, or individually it funds for the faculty to travel abroad under the different schemes. So I have mentioned some of the things like ANRF has ITG scheme, travel grant scheme. Similarly, SIR and SSY from SCRB. AACT has PDS, professional development scheme. And I think this is a FDP program, so it's funded by AACT. STTP also same. Grant of conference, there is one more scheme available in AACT. CSCR has a travel grant scheme for the faculty to travel abroad and present the paper. And in fact, DRDO also funds under the panel of ARB, Aerospace Resource Panel, and the ERIPR scheme. ISRO, ICAR, that is Indian Council of Agricultural Research, or Indian Council of Medical Research, they do funding for academic events. Another question which may be dwelling in everyone's mind is, what funding agencies or reviewers who review the funding proposal look for? First thing, you should have a PhD. Some of the things what I have put, you would not have come across so far, but this is actually a reality. Better you to adapt this. And you should have suppose you write a proposals, which we'll be talking in subsequently. So any proposal should have a support letter from either industry or from the field expert. This support letter will give the confidence to the reviewer that your proposal have gone through well and read by experts, and that's why they give the support letter. In fact, if industry gives it, it implies that this work can be extended as to the commercialization. And as an individual who are writing the proposal, or as a PA who are writing the proposal, you make sure that clear research question is drafted with a very concrete research solution approach. So very, very important is this in your proposal. And you should also mention who are the target beneficiaries out of your research outcome. Let's say if it is the society impact, agriculture related means farmers. Let's say it's a technology related, software solutions means which sector, like a banking sector or a defense sector, whatever. So that target beneficiaries must be mentioned in your research proposals. And we as a reviewer, we look at it, what is the tangible deliverables in your project proposals? Minimum three are expected in your proposals. When I mean deliverable, it's your end research, end output or research output. It's not just a piece of journal papers or anything. It should be either the product or the patent or any kind of IP. So those are the tangible deliverables actually. Or because of this work, how many students are getting trained, or how many PhDs are evolved out. These are the tangible benefits, or the deliverables. And very, very important thing is your research question. Is it explicitly relevant to Government of India national priorities or missions, or does it have social impact, or country's R&D map, does it have any relevance? So you make sure that when you are writing your proposals, how relevant your proposal to Government of India's national priorities or missions or R&D roadmap or Indian society impact. So how to do that? Please go through the website called Principal Scientific Advisor to the Prime Minister, or go to the trust area which are mentioned in major funding bodies, which will give you the idea about national missions, priorities, R&D roadmap of our country. Then when you are writing this proposal, always mention that so-and-so mission or so-and-so national priorities, this is mentioned. Hence, this problem is more relevant to the more relevant to the context of Government of India. And if your proposal has a collaboration with the industry, either as a honorary collaborator or honorary PA, it is much better than not having them. And we look at it, what is the translational potential? Means, does your work lead to any startup? This we will look at it. And make sure that your budget is well justified, whatever you put. Either you don't overcoat, or you don't mention any excessive fund for certain unnecessary things. You make sure that. And in your proposals, you make sure that quarterly outcome what you are going to give or annual outcome what you are going to give. That is the milestones. Okay. And any proposals we are writing, we don't know end result. So definitely there is a technical risk. And you can mention or you may mention the technical risk, what are expected to encounter, and what is the mitigation plans in the event of you face it. And your CV, that is nothing but your team, co-PI, PA, all put together as a CV. Your team expertise should justify that you are more relevant to the research question what you are proposing. I mean, you have a expertise in the field what you are writing the proposals. As a reviewer, when we read what we see, what is the problem statement, why you have written the problem statement, how are you going to solve your problem statement, that is nothing but how to measure the success, and is it just an ambition versus feasibility, we'll look at it, and what benefits government of India or society will get out of your end outcome. These are the things we are asked to grade it, your proposal. Okay. So these 5 slides you keep in mind, just for benefit of all the audience, I have put it up to support the research ecosystem in the country. But any faculties who wanted to have the session on funding proposal schemes in India, or how to write the proposals or thrust area in an extensive manner, stay connected with me. After the talk, I'll give my contacts. You can invite me. We can have a wonderful session for all the faculties, irrespective of the department, for about half day. Okay. So that's about the funding. Let's get into the main theme of today is FDP, that is a functional graded materials. Let me make it very briefly. What is functional graded materials? You take our human bone, which is a functional graded material. If you just cut and see, the porosity gradation will be there. Similarly, in artificial material, if you're able to set up the gradient means like a slope, either in an increasing manner or decreasing manner, either in a linear way or a step way. So in our mechanical engineering or the materials, what are the variability we can bring in the material? One is the chemical composition. Second is a microstructure, which we call it phases, like arsenate, martensite kind of a phases. Third is the properties. So either I can vary gradually in functional graded composites, or like a step wise. Like you just take an example of staircase. Those are steps. Each step, the composition or the structure remains same. When you go to the next step, the difference is built. Likewise, you can have a stepwise gradient. So what is the benefit you do by having the linear gradient or stepwise gradient? There is a smooth transition in the property variation across the section, so that you don't have any sharp interface in your material. If you have a sharp interface, you will face a lot of issues at the interface, mainly the cracking or the material failure. But everything you are bringing in a single material, that's why it's called functionally graded materials. What is the use of it? The goal is, suppose you try to make a material with very strong way, it doesn't have a toughness or the ductility. Okay. Or if you're trying to make it very stiff material, it may not be flexible. If you want to make material with very high wear resistance, it is difficult for you to machine because it's very hard. Likewise, there are properties which are dichotomic or paradoxical. Can I bring and optimize this dichotomic property in a single material? Yes, it is possible through the approach called functional graded materials, like setting up the linear gradient or a stepwise gradient. So we will look at it one by one, and I'm going to only give you what are the proposals you can write. I just give a very brief about what is functional graded materials. So where all we can use these functional graded materials, we will see. Wherever I face the problem of stress management or strain management, what is stress management and strain management? Let's say I have a soft phase and hard phase. I wanted to integrate these two in a material. For example, your gear applications, you want a tough core, okay, hard casings. But if I have a steel with a plastic and stick to it together, you cannot make it, because both are not compatible. But if I set up the gradient from the plastic to the metal, that is a soft phase to the hard phase. Can you mute? Some disturbance are there. So could you please mute others? who are making the disturbance, or you can just throw them out from this talk. Yeah. So when you have a smooth transition from the soft to the hard, you can manage the stress and strain. So, for example, when I have a coefficient of thermal mismatch, which leads to the cracking at the interface. So, when I wanted to manage these kind of either hard and soft phases or thermal mismatch, I can use this functional graded approach. This mainly helps you to get a properties which are not achievable in or optimizable in a single material. And there are cases where I want to improve the performance of the existing components, like either wear resistance and toughness or corrosion resistance in a single part. At the same time, I want to make the part very lighter and stronger and more durable, where I can use it. Especially in the biomedical industries, biofunctionality and integration, like a bone implant or a tissue integrations, where I may need to set up the porosity gradients or the ceramic with metal gradient, have a more biocompatibility or to accelerate the bonding of tissue, living tissue into the existing implants, or make the implants to integrate very quickly with the human bodies. Those areas, functional gradient materials will be very useful. And in fact, in all your bone implants, if you go and look at it, they set up the porosity gradients mainly to minimize the stress shielding. If I don't create that kind of a functional graded structure, your bone, natural bone will not grow, or natural tissue on the implants will not grow. Over the period, your implant will get loosened and it will become a separate and it will lose its purpose. In fact, your bone also, whatever develops, will become weakened and disintegrated or reabsorbed by the human body. And crashworthiness applications, so wherever I need to absorb the energy or wherever I need to protect from the high energies, for example, armor plates, blast protections, those areas, I can use the functional gradient structures, at the same time maintaining the weight. Lastly, wherever I have a material to be used in the harsh conditions, marine environment, aerospace environment, nuclear energy environment, where I want to improve the life of the components, gradient structure helps you. Okay. So this gradation or gradient is not just a material choice, it's a design philosophy that integrates microstructure, function, and performance in one engineered system, a single system. Now, I'm going to talk about each sector wise, what are the problem statements, research proposals you can write. Right? So let's start with the automobile sector and the EV sector. See, there are plenty of problems in this sector. I have just carefully selected very important and very pertinent problem presently faced in this sector relevant to the functional graded materials. So 4 applications I propose. One is the brake disc. Second is the piston liners we see in our IC engine. And in EV vehicle, we have battery pack heat spreaders, noise vibration harness panels. So these 4 applications have taken. And the first one, what you see will be the currently used material, and how to make functional gradation is the next material you will see. So if currently cast iron is used because you have a graphite lubricant inside and it has a very good tribological properties. But when I expose this cast iron to the high energy braking conditions, because of the high temperature, thermal softening happens, it loses its thermal performance. In other words, wear resistance also will be poor, the life will get affected. Braking performance is also poor because of the high temperature assisted thermal fad, we call it brake fad problem. So the coefficient of friction will lose with the increasing temperature. So how to avoid? I have a cast iron, and on top of it, I will have yttria stabilized zirconia or resin bonded silicon carbide. That is a ceramic. So I have alloy. On top of it, I'll have a ceramics. But I will not have alloy and ceramic bonded together or welded together. I will increase the YZ, that is yttrium stabilized zirconia percentage, let's say from 0 on the surface of cast iron to 100. So I will create the linear graded structure. So mainly to improve the performance of the brake disc. And piston usage in IC engine, you may be knowing, which is exposed to very high temperature, hot gases. Okay, so how to improve its life? So I can use a high temperature material like Inconel 708 superalloys. Despite of using that, I face the corrosion resistance issue, hot corrosion resistance issue, and thermal softening issue over the period of time. So how to avoid it? I can apply the same yttrium stabilizer zirconia coating on top of it in a graded manner. So which helps me to give you from the brittle to the ductile, brittle ceramic layer to the ductile Inconel 709. At the same time, because of the ceramic which has a very high heat resistance, my life of the component gets improved. And ceramic gets never corroded. So my corrosion resistance also is getting improved. Coming to the 1 second. Battery pack heat spreader, which is used in the EV batteries. So the job of heat spreader is to take out the heat, spread it evenly out of the battery pack, so that there are no hot spots on the battery pack which deteriorate its performance and the life. So conventionally, people use oxygen-free high conductivity copper because it has a very high thermal conductivity. But moment you use only copper, what happens is all the heat will get transmitted or conducted by thermal this copper. But the copper does not have enough strength at the higher temperature. So the life of this heat spreader will be low. So instead, I can add one more layer called aluminum to make the lightweight. At the same time, metal to metal bonding is very good. Then I will have one more ceramic aluminum nitride. So inner casing will be copper. The next layer will be 6061. On top of it, you have aluminum nitride graded plates. So what I'm essentially going to derive out of it, this aluminum will give you the good bonding between the either sides. That is copper as well as on the ceramic side, aluminum nitride. Also make your entire weight of the heat spreader to come down. And this aluminum nitride will have a good coefficient of thermal expansion matching with the aluminum alloy. So there will not be any problem at the interface. If I use only copper and ALN, then I may face a problem of CTE mismatch leading to the spalling and cracking at the interface. So I derive the multiple benefits of better thermal conductivity, so I can avoid the heat spots. So there are no heat spots or heat concentration inside your battery pack. So life is improved, and most importantly, heat is distributed out of your battery pack. Lastly, noise vibration harness panels. So currently people use low carbon steel sheet because it has a very high stiffness. Plus they'll add the butyl rubber damping layer to have a high damping capacity. So patched steel with rubber. On top of it, you put glass fiber reinforced epoxy, that is to reduce your weight, because CFRP has a low weight. And now for the stiffness, you have a steel sheet. For a damping capacity, you have a butyl rubber. To reduce the weight, you have a glass fiber reinforced epoxy. So when you integrate this kind of a structure, you can derive the multiple benefits. One is to minimize the noise and vibrations and improve the stiffness of your product and reduce the weight of the product. So that's the way you can set up the functional gradient structure. It can be a stepwise gradient rather than the linear gradient. Yeah. Then coming to the biomedical industry, your hip dental implants, if you go back and see, presently people use only a single material Ti64, but in research perspective, you can have dense core of Ti64, titanium 6 aluminum 4 vanadium. On top of it, you can have a porous porous structure of titanium 6 aluminum 7 niobium. When you have a porous surface and when you integrate into your human body, the porosities will act as a space for the human tissue to grow. The integration to the human body will be facilitated very easily. And instead of in a month, within few days, you can see the bone integration or the hip implant integration to the body is very effective. Maybe about a couple of months later, you can see the good amount of tissue growth or the new bone growth in that area. Otherwise, what will happen? Stress shielding will happen. If I have only dense material, leads to the loosening of your implant, and again you have to refit it. Similarly, you would have come across hydroxy peptide, that is HA, which is a bioactive material. Titanium is a biocompatible material to the human body. So how they do it? They'll put the titanium on the top, and they will coat it with a hydroxy peptide bioactive coating in a functionally graded manner, so that this titanium with the ceramic, hydroxy peptide is the ceramics, the bonding will be very good, and this you will have a gradient from titanium rich interface to the HA rich bioactive surfaces. When you expose the bioactive surface to the human body, whatever requirements like a tissue growth or cell growth become very easy. And recently, with the advent of additive manufacturing, in fact, we have a flexibility to make patient-friendly or patient-specific AM, implants. For example, Ti-64 lattice structure implants with a porosity from 80% to 20%. I mean, the core you have 20 and on the surface you have 80. Because the one which is exposed to the human body should have more porosities, so that the integration will be very easy and tissue growth will start very early and quickly and more effectively. These are all this kind of a lattice structure will help you to minimize the stress shielding and improve the patient's recovery quickly, process quickly, and the implant effectiveness will be much higher. Then coming to the aerospace and aerospace sector, space sector mainly, we use in turbine blades thermal barrier coating. Okay, so this coating is a ceramic coating, yttrium stabilized zirconia on the nickel-based superalloy, and the temperature it is exposed to is in the order of 1200 degrees Celsius. So only yttrium stabilized zirconia will help us. Even in fact, your superalloys will creep at that temperature. So how they do make it? They will have a nickel-based superalloy. On top of it, they will have a bond coat, so that the CTE mismatch, coefficient of thermal mismatch between the ceramic and superalloy is minimized. And this bond coat also will help you to improve the oxidation resistance. And zirconia will give you the high hot corrosion resistance, erosion resistance, and creep resistance, and most importantly, high thermal resistance. This is all the properties you will be getting when you have a gradient structure of yttrium stabilized zirconia on the superalloy. Similarly, in our rockets, re-entry vehicles, the rocket nozzles are re-entry vehicles leading edges. Okay, it enters to the Earth orbit at a very high speed, so which results to the very high friction, leads to the temperature is in the order of 2000 plus degrees Celsius. So if you have a metallic structure, it will oxidize. Okay, and if you have a composite structures or ceramic structures, it may face a different problem. So in this kind of a very harsh environment, presently people use carbon-carbon composite because it has a very high melting point and fabricability is easy. But the problem with the carbon-carbon composite is it has a poor oxidation resistance, okay, and poor thermal shock resistance. So in order to improve that, it is coated with silicon carbide. On top of it, if your re-entry speed is, the velocity is very high, they will coat on top of it hafnium carbide. That is much high, ultra high temperature resistance material, ceramic. So in your proposals, what you can write for these applications, this material gradient you can apply, and you can characterize its property to look at this material fits to the specific application what we mentioned. Similarly, acoustic or thermal protection panels, which we use in the aircraft structure or the space structures, where I need a very high stiffness and very high damping capacity, and both are contradictory to each other. So what is the future in this area is make the foam structures like a foam cores, aluminum foam cores. On top of it, you have a composites for the stiffness. On top of it, you have a ceramic for the thermal protections. Alumina is generally added on top of it. And wherever I face the CTE mismatch joints, where I try to join metal with ceramic, usually we set up the gradient structure in between. So there is a smooth gradient between metal and ceramic. For instance, if I want to do the dissimilar joints like 304 stainless steel, which gives a very high corrosion resistance, but it is very ductile and poor strength, with very high thermal resistance, that is alumina, Al2O3. Okay, I put in between a molybdenum interlayer so that CTE mismatch between the steel and alumina is minimized. So when I have a molybdenum which has a very high melting point and which has a CTE close to the alumina, it can very well bond with alumina, ceramic. Whereas aluminium, steel and molybdenum, both are metal in nature. So they can diffuse at higher temperature and form the strong interface. So that is the way CTE match joints are developed in the aerospace industries. I think I have another 30 minutes. I quickly run through only the project proposal ideas, then I'll take up the questions. In the area of defense, where I'm working on the protective systems, armor plates is one applications where enemy shoots you, how to protect the bodyguards, and transparent armor where you can see through it, especially in the aircraft windshield and canopy kind of areas where any shooting happens. You should have a visibility there, and at the same time it should provide the protections. Or in the army tank, so there you need a transparent armors. Then blast absorbers. So when you are in a war scenario where any blast happens, how you can protect yourselves. So in all these scenario, the logic is very simple. You should have a hard casing, tough core. So hard casing usually from the ceramics like a boron carbide, silicon carbide, or aluminum oxide if you want a transparency. Okay, so this can be obtained through this kind of a hard casings obtained from the ceramic, and soft or the tough core either through aluminum because of its lightweight or titanium. So 7075 has a high strength aluminum alloy. Ti64 is another high strength titanium alloy, or polymer like polycarbonate. Okay, so when you integrate the structure in a gradient manner, you derive the dual benefits of both hardness, strength, impact resistance with the impact toughness. Okay, so which is not available or feasible with a monolithic material or a single material. If I use only aluminum or titanium or ceramic, you don't get this. So you need to have this gradient structure to benefit the dual dichotomic properties. Similarly, in the blast absorber scenario, we use the aluminum foam with the graded porosities. So usually the surface layer with high porosities, and as you progress from surface to the core, the density increases. So when any blast happens, most of the energy will be absorbed by crushing of the surface of the foam. When the shock wave transfers inside, the dense structure will give the shock resistance. So that is the way the blast shock waves are absorbed in the blast absorber materials. So additive manufacturing is one of the prominent technology to develop this kind of foams with the gradient structure, density gradient structures. Then energy sector or oil and gas sector, if you want to work in the functional graded materials, 3 applications I have put. One is a heat exchanger, another one is solid oxide fuel cell interconnects, third is the valve seats. So all the cases you can see, you will have a high temperature material alloy or the steels, superalloys or steels will be in the core. On top of it, you will be having the ceramics like a carbides, chromium carbide, or lanthanum cerium manganese oxides, or tungsten carbide cobalt overlay. So the idea is again a hard casings, tough core. The tough core will have a high temperature property also. Okay. The ceramic, the advantage of the ceramic is it has a very good thermal resistance, very good tribological properties, mainly the wear resistance or the erosion resistance or the corrosion resistance. Okay. So these advantages you can get it from the ceramic. High temperature strength you can get it from the tough core, and most importantly toughness and ductility you will get it from the core. Okay, these are the prominent material used in column 625 for the heat exchanger. In solid oxide fuel cells, there is a special ferritic stainless steel called Grapher 222 APU steel. And stellite is the cobalt-based superalloys used in the valve seats. On top of it, you'll have ceramics. So the end application or end benefits, the hard casings will give thermal protection, tribological protection, corrosion protections. A tough core will give you the ductility, toughness, or energy absorption, in addition to the cases where you have high temperature properties. So please note down these materials where you can start doing the research. Then if you are interested in heavy industries, tooling industries, or manufacturing, so you come across in machining, cutting tools, or casting, forging industries, you see the dies and molds, and AM, additive manufacturing inserts. Okay. So if you take the machining tools, so you need to have a hard, extremely high hardness on the surface to have give a very high cutting force. At the same time, it should be tough enough to, prevent the catastrophic brittle fracture. So tungsten carbide is the very famous cemented carbide tool in the cutting tool industries, which is usually processed through powder metallurgy with cobalt as an another ingredient, which act as a liquid phase sintering agent in that. So when you vary this cobalt content, you can increase either the hardness or the toughness depending on the cobalt increase or decrease. Similarly, in the dies, H13 tool steel, which is a very famous tool steel, tool steel is used to make the dies or the molds for the sand casting or investment casting, sand casting or the pressure die casting dies, or the forging dies or extrusion dies. So if you coat that with ceramic like yttrium stabilized zirconia or aluminum oxide, zirconium oxide, this helps to provide you the thermal shock resistance, because you have a rapid heating and cooling cycles in the dies, either in the forging or the casting process. So it needs a high thermal shock resistance, which can be offered by these ceramic coatings. Similarly, if I have a die channel or the conformal cooling channels, usually if I make it with a monolithic maraging steel, kind of high strength steel, I don't have a high thermal conductivity advantages. In order to create this high conductivity advantages, only the internal channels I can either coat it with the copper, or through some way I can create the copper gradient from the base of the steel. So this helped me to accelerate the cooling rate. So in sand casting kind of a scenario, or in die casting kind of a scenario, your property of the end component depends on the cooling rate what your die provides. Higher the cooling rate, finer the grain size, better the properties. That's a simple logic. At the same time, life of the component also depends on its thermal shock resistance mainly. So if I have this kind of a gradient structure, I can improve the cooling rates or properties of the final product will be better. At the same time, I can quickly cool so that my productivity increases by reducing the cycle time, and dimensional accuracy also is better. Then comes to the electronics thermal management industries. In the electronics industries, what mainly we face, semiconductors emits heat. Okay, and this heat can be should be removed from the circuit, otherwise it damages circuit by creating the hot spots. Or the semiconductor may need to get integrated with some other casings. Because of the CTE mismatch, some issues we may face, like a delamination kind of issue. And radio frequency components where I need to have a low loss, especially dielectric loss, I need some kind of a different kind of a materials. So we'll go through one by one. If you're interested in metal matrix composites, either you work on aluminum silicon carbide, don't characterize its wear or tribological properties. Instead, you characterize its thermal properties. Copper with synthetic diamond. This is a very famous material in the thermal management applications because copper have very high thermal conductivity. Diamond also has very high thermal conductivity. By adding the diamond, I can improvise its strength properties. And CT mismatch also is very less. And moment you add diamond to the copper, the composite CTE will come down, which will have very good matching with the semiconductor chips. Similar, if you want a lighter weight one, you go for aluminum silicon carbide. Among all the ceramics, silicon carbide is the only ceramic which has a very high thermal conductivity. So when I integrate lightweight material with a lightweight ceramic, I can derive the very lightweight structure which has a CTE matching with the semiconductor. Similarly, heat spreader, which we talked about in EV vehicle. So if I wanted to, copper though has a very high thermal conductivity, the strength wise, copper has a very poor strength. Okay, in order to improve its strength, you can alloy it. So molybdenum is one of the very good alloying elements. And most importantly, when you alloy with the copper, it brings down
Sir, it is not audible, sir.
Slides are visible, sir. How about slides are moving? No? Okay. Just I'll take 2-3 minutes before I wind up my presentation. So one of my PhD scholar has recently started the consultancy to support all the. Yeah. So people who are interested in to do the research projects or proposals or PhD results, for them this startup has been started. Even for the institute students training. So what are the offers are the products offered to this academic project supports area by my student? One is simulation and software for 3D printing, powder supply to do the research in the additive manufacturing, coating and composites. And in fact, if you want to set up the center of excellence, there are affordable 3D printers in metals and ceramics. See offers. And people who are interested in polymer composites, processing, testing, yes, there are testing setups and process setups are available which can be used for your PhD research or UG/PG research or the project proposals executions. In fact, the company has a contact with abroad to procure the aerospace grade alloy bars for the academic research. Similarly, 3D printed metal alloys bars. So I quickly tell you what are available. 3D printing software, so which can do the multi-scale, multi-physics simulations, which is a AI empowered image analysis. What help it can do to the academicians? You can use this software to do the simulation, write a very high quality journal papers and patents. And whenever you write any proposals which needs the simulations, so this software can be used. And the software cost is around 1 lakh to 5 lakhs for a few licenses. And most importantly, if you have the software, your students will get empowered, especially it makes them to be industry ready in the field of aerospace and defense and biomedical and manufacturing sector. So any college or faculty needed this software, you can approach either me, I can connect you with the consultant, or directly the consultant, that number is given over there. Then the lot of faculties will be finding difficulty to procure the materials in a low quantity, because academic research needs the low quantities. If you're interested in nickel-based superalloys or cobalt-based superalloys or iron-based alloys or tungsten carbide kind of ceramics, which can be used for the coating application, additive manufacturing, cladding, thermal spray, friction stir processing kind of applications, or composite development, you can use these powders. And you can study a number of things like wear or corrosion or erosion or mechanical, thermal or tribological. So this work can be used to produce the papers, patents, and theses. So if you want any powder to be procured in a low order quantity, you can approach. Then similarly, if your college wanted to set up the center of excellence in the field of polymer or metal 3D printer, there are wide variety of printers. There are wide variety of printers are available in a different size ranges. Size starting from 68 mm to 500 mm means build volume. Such a kind of a parts, from small size to big parts, you can produce, and this can help research in across all the disciplines, mechanical engineering to the aerospace to the biomedical to the even in fact for circuit board printing like ECE, electronics, robotics, they can also use these 3D printers. If you're interested in polymer composite development, either through hand layup or vacuum infusion molding, there are setups available with the furnaces, so you can approach anything related to the polymer composite processing. And metal or alloy or composites or additive manufactured parts or welded or anything you want to test it, these are the testing facilities available where you can get access through this startup. Okay. Most importantly, all the polymer composite tests are available, and tribology and mechanical as well. Lastly, some researchers are very much keen on exploring the aerospace grade materials, but you don't get anywhere in the country. So this startup has a tie-up with the abroad, so they can get you the less quantity for you for your research. Yeah, very exotic material where there are no research published in the journals. So it is easy if you work on these alloys to get published in the journal. And ideally, you can do the work on tribology, erosions, friction stir processing, welding, coating, machining, corrosion-related projects. Either UG or PG, or even you can set up the PhD problems out of this material, because these materials, the publications are very, very less. And you don't see the publications because these are on the aerospace grades, very rarely available in Indian country. Similarly, 3D printing is another advanced technology. So through laser powder bed fusion machine, printed samples are available. There are variety of materials in the category of aluminum, titanium, high alloy steels, and super alloys. So any material you want to procure for your academic research, so you can approach us. And my final slide, last before the slide, I work extensively in the field of machine learning recently. 3D printing, I have done quite a lot of work for the last 5 years, so I'm moving out of that, although I can help you. How to apply this machine learning to the materials and manufacturing domain. So this is my academic interest. In the industry, I support the industries who are into 3D printing and coating as a mentor for many startups. Similarly, for the academic institution as our universities, I help them in setting up center of excellence or testing labs or incubation center in the field of machine learning, IoT, drones and composites, and 3D printing and coating. Lastly, I am currently serving as an advisor for many institutions across country, prominently NIT Trichy, Andhra Pradesh, Anna University, where I am acting as a board of members. In addition, I help them in acting as the research council member or the academic council member to support their institute development. So anyone needs any help, you can always approach me. I'm approachable easily through WhatsApp or email. So I'll be happy to help any of the faculties who are interested. So with this, I just concluded. Any questions are there, please post it on the chat box. I'll just read and answer one by one. Okay. With this, I thank Dr. Danbal for the wonderful opportunity and platform. And Friday, once again, I'll come back with the specific project proposal ideas in the 3D printing mainly. So I'll discuss only project proposal ideas in the 3D printing on Friday as a last session. With this, I thank you. I'll get back to the web brochure where I can see your questions and I will start answering. So you people are free to contact me. Thank you. I am unable to see the message box here. So if you could either read the questions, organizer, so I can answer. Dr. Dhanapal, I'm unable to see any message box here. I don't know whether you have access or not. If you have access, please read, I will answer. Or if there are no questions, please wind up the session. We'll meet on Friday. Dr. Dhanapal? Hello? You are audible, sir. Please tell me. Okay.
Sir, so sorry to dis.
There are some faculty raising their hands so they can unmute and speak, not an issue.
Sir, sorry, sir. I
Yeah.
may let me know.
Yeah, people can unmute and ask one by one. No, Mr. Balaguru wanted to ask something. What I see.
Sir, my voice is audible, sir.
Yeah, your voice is audible. Go ahead, sir.
Yes, sir. Yes, sir. Sir, next session I'm going to give, sir. Okay, let me introduce myself, sir. I am working in 3D printing company, sir. Okay.
All right.
Okay, sir. Sir, do you working in any biomaterials, sir? Like tissue
No,
kind
sir,
of working?
I exclusively serve for our country armed forces. In
Okay,
this,
sir.
mainly, we use laser powder bed fusion techniques to fabricate the parts for our military aircrafts and engines and helicopters. So I'm not into any biological or related activities, actually.
Okay, sir. Thanks. Yeah. Sir, thanks for your information, sir. Okay, sir.
Right.
Sir, I will connect with to LinkedIn or some other social network.
Please, please. You're welcome, sir. You're welcome.
Okay. Thanks. Your session is very wonderful, sir. Okay.
Thank you, sir. Thank you, sir. Address Dr. Dhanapal, I think next speaker is already waiting. So may I take your permission to leave? All right. Thank you. Thank you all.
Thank you, sir. Thank you so much for your valuable presentation, sir. Thank you.
Dhanpal sir, you are not sending any attendance sheet, sir. Please share. Yes, sir.
Yes, sir. Yes, sir. Audible, sir.
Please, sir, please share the attendance sheet and the feedback link also. Please share the attendance sheet and the feedback link also.
Sure, ma'am. At the end of the session, sir will share the details. Please wait.
Okay, thank you.
Hi everyone. This is Bala Group. I'm working as a senior application engineer in Montech Systems Limited. Okay. Anyone can tell my screen is visible to everyone and my voice is audible. Anyone please answer.
Yes, sir. Yes, sir.
All
Visible,
clear,
sir.
sir.
No issue.
Okay.
Yes, sir.
Okay. Let me introduce myself. Okay. I am a PG graduate from PG College of Technology. Very well to everyone. Okay, maybe some of them known to me. Okay, okay. I already have sessions with our Dhanabal sir. Okay, I am thankful for a wonderful session and a very good evening to one and all. And I am thankful to like AICTE as well as the management of ISA College of Technology. Okay, I am going to give some glimpse about this additive manufacturing technology. Okay. Then I am like previously I worked as an along with under the guidance of Dhanabal sir for 6 years in Karpam Institute of Technology, Coimbatore, and then I joined as an design engineer in a tool room. Elegance Engineering is in Coimbatore, Ganapati. Okay, I served there for 4 years in plastics, molds, and some additive manufacturing and some scanning services, reverse engineering, and all. Then I moved to Monotech Systems Limited. Like this is a 25 years old company. Okay, and I am here sir for past 3.5 years. Okay, and then this Monotech Monotech Systems Limited is a very well known company for a past 25 years, and then they are located at 18 different locations all over India, and then we are selling the equipments like 2D printers as well as 3D printers in all over India, and we having a support services in major cities we are covering. And we in 3D printing we are working in all categories like polymers, metal, ceramics, thermoplastics, thermosetting plastics, waxes, composites, and some color models. Okay. And we having a experience center in Chennai with completing with 9 different technologies, which includes 9 different type of 3D printers as well as 4D printers and some scanners also we having. We are helping the technologies future technologies to the industry, introduced into the industries, and we are solving their problems. Okay, like real time problems we are solving, and we are providing like best solutions to the industry, as well as we are closely work with different IITs like IIT Madras and DRDO, as well as NAL, HAL, and different type of DRDO organizations we are working for different services. And we are partnered with different OEMs like Faforge from India. They are located at Coimbatore only, very near to the Park College and our PhD college, New College. And they are into institution 3D printers as well as make 3D printers. They are very good at research works, and then they are supplied with the different colleges. Amrita College, they covered Amrita College, IIT Madras, NITTR, and different IIIT TM, NIT Trichy, then some CSR labs like food technology labs located at Mysore, and TNAU, they supplied their machines. They are working very good research in biomaterials, this particular topic into biomaterials, they providing solutions through FabForge. We are providing solutions through FabForge, through some medical colleges, like even Savita, the FabForge machines are supplied, they are working well, and some SRM universities in Trichy, they supplied in VAT for different departments like mechanical, then some 6 different type of paste extrusion 3D printers in biomaterials. They are working in VAT Vellore. Okay, and in Whaltech also they are using these FabForge machines. So it is they are very good at it. And Amrita, they are covered with all the three units. Like Amrita, they are using it from Dr. Ram Murugan sir. They are using the paste extrusion printers, and they publish some papers to the FabForge. And in Amrita campus, like Kollam campus, they are using the machine. They are with some peak with some hepatite board like materials and all. They are made with those FabForge printers, and then they are providing. They make some research works, good research work. They published with some reputed journals. Okay, this is like FabForge India, FabForge from India. Then we are partnered with Marforged, some of like a very well-known company. They are operating from past like 13 to 14 years. They are in the market. They are having like a very good aluminum equivalent strength composite materials and all making through the Marforged from USA. And then big up into like very large format FDM printers. They are into like industrial-based printers with 1 meter bed size. And then WTP from Australia for like DLP solutions, and Meltio from Spain, USA, they are very good at like wire-based, like metal wires converted into some useful parts with useful parts for like biomaterials, as well as like industrial applications for manifolds, and some other like what are the industries are they in the demand? They are utilizing the Meltio with the LMD technology, like laser form of research is used to melt those wires, and then they made some of the parts, and then they are giving like combined solutions with hybrid solutions. Okay, the same meltio head with the CNC as well as robo, and then they are making the parts without supports. And 3 from the Netherlands is a very good company for filament making solutions. Okay, we are like more than like 30 different type of composite materials we developed. Some of the colleges here, well-known colleges, K. Ramakrishna, PhD College of Technology and all, we are closely working for SRM College, Rajalakshmi College, and some of the college, St. Peter's and St. Joseph and ACS College from Mysore. And these 3 is recently purchased by VAT Vellore, VAT Chennai. We like 1 week before we installed these 3-door filament maker, like a very good filament maker, and listen like a desktop filament maker. And we are partnered with the farmers from USA. They are some of the guys know for like SLA as well as SLS 3D printing solutions. And then Mimaki printer from Japan. They are into like color models for education models, as well as like different type of models, different color models for education purpose as well as surgical purpose. They are using these color 3D printers. And FlashForce from China. They are into like jewelry making printers, jewelry wax models are printed, and then they supply to in the market. Like in Coimbatore also for jewelry customers using those machines. And then Thor range vision are for like scanning solutions. Okay, like handheld scanners as well as fixed scanners for accuracy from like 10 microns to 100 microns. There is different ranges is there. And then post processing from USA, it's due to the sustainability and all, like they're using this post process. And Creality from China into like a very good FDA market, you know. And then Ermaxon from Turkey, they are into like a powder based printer. Okay, sorry for just a minute, I will come back. Sorry, I'll let me continue. And then how we evaluated this additive manufacturing technique. You know, every college is having some basic FDM printers from Creality or some Bamboo Lab or their own bake. Nowadays is there. Okay, you know the FDM printers. It is printing by layer web. It is It is from like what we are using, like household house, how we are like building and all. As the same kind of additive manufacturing is there. Okay, we are creating the layer by layer. It's the same like floors, walls is there. Okay, same like that. And then compared into the subtractive manufacturing, it is evaluated from our rocket caves. You know, it is very popular at Mahabalipuram and some other historic places is there. They are using already the subtractive manufacturing. What we are using like a CNC or milling or some other like a drilling operation, they already evaluated from our nature only. We are using this EAM and like additive manufacturing, subtractive manufacturing and all we are using. And then we everybody know the 3D printing process is one subset of additive manufacturing. There is a lot of additive manufacturing is there. 3D printing is one of the subsets. And then these parts required some CAD model to create those objects. Those CAD models are created from any software, very well known with SolidWorks or AutoCAD or some other like Creo or CATIA. Using those softwares, we can create a CAD model. Those create the CAD model is like converted into a like STL. Then those STL softwares is the input of a slicing software. Like for FDM printers, we are using like open source Cura or like simplified 3D or you know the Creality. They having like different software or any other DLP softwares. Like DLP or SLA, those are all like OEMs. They are making their own slicing software and then they are slicing. Okay, then those using those slicing software, we can slice us and then we can get a tool path in terms of like PNG or JPEG image is used in like in DLP technology or like SLA technologies or LCD technologies, and some G codes like G codes are for FDM technology we are using. Those slicing or toolbars are sent into a 3D printer, and then we can create the object. After creating the object, there is a need of some post-processing techniques to remove those support areas, and as well as for like we can get in like very good smooth surface finish or like painting process are going for in that post-processing stage. This is like an overview of a 3D printing process. Then there are different type of AA processes there. One is that like material extrusion technique, like a triple process is there. Then